Hello everyone, welcome to the Let's Get Solving with Google Cloud series. My name is Srinivas Makam. I'm a customer engineer focusing on application modernization within the Google Cloud team. So this is a third of the fourth part series on Kubernetes and Google Kubernetes Engine. In the first two parts, we covered about how do we migrate an application running in a VM to a container in Google Kubernetes Engine. In the second part, we covered about how do we secure our clusters as well as applications running inside the Google Kubernetes Engine. In this part, we are going to focus on how do we do troubleshooting within Google Kubernetes Engine, right? And what we're going to use is, the Stackdriver or the cloud operations features in the Google Cloud that includes monitoring, logging, as well as APM. In the last part, we will focus on how do we deploy a serverless application into Google Kubernetes Engine. So before we get started with the lab itself, I kind of wanted to talk briefly about, how the Stackdriver or cloud operations is architected within the Google Cloud Platform, how it's integrated with GCP as well as with Google Kubernetes Engine. So if you look at it, right, within Google Cloud, cloud operations is a broad suite of products, right, which is integrated with every product within Google Cloud, right? Whether it is a compute engine, storage, BigQuery, any data services, everything is integrated with cloud operations. So all the monitoring and logging goes to the central location. So not just monitoring and the logging, even the APM related information that includes your tracing, debugging, profiling, they all go to the central location. Now, specifically with respect to Google Kubernetes Engine, so you have different kinds of logs and statistics that you need to monitor, right? One is at the cluster level you need to monitor, at the node level you need to monitor, and then you have your services, deployments, pods, you need to monitor, statistics at different level. And all these things are monitored by agents that sit inside the cluster. So it's a distributed kind of a model. And this goes to the central Stackdriver. And here we can go and look at the logs, we can set up some different filters, look at the monitoring, set up different alerts, all that can be done. So not just that, these logs can also be exported. Let's say if you want to do archival, you can send it to cloud storage, or you can send it to BigQuery, or let's say if you want to send it to an external storage system, you can do that as well, right? So very flexible in terms of how the system is integrated together. Now what we're going to do in this specific lab is we're going to create a Kubernetes cluster. We're going to deploy a microservices application called as a hipster shop. So this is going to be an e-commerce application with a whole bunch of microservices. And if you look here, right, from the internet, you access the front-end service. Front-end service calls checkout, payment, ad, email, currency, recommendation, a whole bunch of services, right? This is typically how you would deploy a microservices based architecture. So what we are going to do is look at how we can monitor these different services, how we can do logging, how I can set up alerts for different metrics that I want to monitor. All those things we're going to observe in this specific lab. So let's jump right into the lab. So this is the QR code that you can use to get started with the Qwiklabs, and it's important that you use this specific QR code because when you use this QR code and run through this lab, you get 1 month of free credit, which is pretty good. You can run through any of the Qwiklabs with this. So by the way, when you use this QR code, you're going to get pointed to the first lab of this series, which is migrating VM to containers. So once you run through that lab, then you can run through this specific lab as well as any other lab that you want to run through. All right, so let's go to this lab that we want to run through, right? So this is the lab that we're going to run through. Let's first start the lab. This lab will take around 3 minutes to start up. The reason being, what it will do is it will create a Google Compute Google Cloud Sandbox, and within the sandbox it's going to pre-create the cluster, so we don't need to create the cluster. So that's why it's going to take around 2 to 2.5 minutes. So while this provisioning is running through, what we will do is we'll kind of run through this lab and look at what we are going to do in this specific lab, right? All right, so first we are going to do is as soon as this lab environment is up, we will look at the clusters, and we're going to have one cluster with 2 nodes that is pre-provisioned for us. Next, we will create a monitoring workspace. A monitoring workspace within Stackdriver means that it has a collection of all the resources set up for us, and we can put multiple projects within a workspace, and we can monitor all of them in one single workspace, right? So that's kind of what a monitoring workspace will do. After this, what we will do is we will clone this repository which has the hipster shop application, and once we clone this, we will install a tool called a Scaffold. So Scaffold is a developer based mini CI/CD tool. What it will do is it is a quick deployment tool. It will look for changes in our current environment. If there are any changes, it will automatically build the container image and deploy it in a single step, right? So that's an advantage with Scaffold. So basically, once I install Scaffold, and if I do a Scaffold run, it's going to pretty much do all the deployment to the Kubernetes cluster, right? So after this, when I look at the pods, I'm going to see all the different pods associated with the servers running. So this is the first step of this. So we look at the external IP, and then we will access this particular application and see that everything is running fine, right? So that's the first step. So after that, what we are also going to do is check out the source code associated with this application. And what I will also show you is how do you basically instrument your source code so that you can get profiling as well as tracing information, right? Because I told you that we are going to also do tracing and profiling for this particular application, right? So we will do that. All right. Once at this point the application is deployed, I will show you how do you do simple monitoring and logging for this application, right? I'll show you the monitoring dashboard, logging dashboard, simple statistics, how we can collect, right? As a basic debugging, I'll show you at that point. The next step, what we will do is we will set up something called as a service level objective. So what is service level objective and service level indicator, right? A service level indicator is kind of golden metrics for any application or service, and typically we call it as 4 golden metrics. First is the latency, second is the error rate, third is the system throughput, and fourth is the availability, right? These are kind of the metrics that we typically use to judge how our application or service is performing, right? And for every application or service, typically we can set up an objective and say that if this objective is not met, give me an alert, right? Which means something is going wrong, and before it goes wrong, I want to get an alert that something is going to go wrong, right? So these are typically good, I would say, SRE best practices that we can follow when we are deploying microservices at scale, right? So by the way, the lab environment is set up now. We can see the username and password, so we'll come to it in just a few minutes. So now that I talked about what a service level indicator is, service level objective is, what we are going to do is that we're going to set up 2 service level objectives, right? The first objective we are going to do is for the request latency for one of the microservices which we call as a front-end microservice. So what we will set up here is we will set up an alert such a way that if 99% of my requests from the previous 60-second period is within a particular threshold, I'm good. If it is above the particular threshold, I want to get an alert, right? So that is the first objective we will set. And the second objective we will set is we'll pick out one particular microservice and say that if there are at least one error within the 60-second period, we will set up an alert for it, right? So that's what, or the 2 alerts we will set up. And then what we will do is we will monitor the latency, right? And typically, for the front-end service, the latency would be less than 2 seconds, and we will not get any alerts, right? So that is what we will demonstrate in the first case. And what we will do after that is that we will deploy a new service, right? Which basically has a bug in it, which will cause the latency to go more than 2 seconds. And then we will show that we will get an alert, right? And that's kind of, we'll deploy the new service, and we will do some we'll do some shopping in the website, and when we will see the violation, right? And we can acknowledge the violation, we can get emails, we can get different ways to trigger this violation. And once this violation is triggered, and I will show you, I'll go to the trace in the APM, right, I'll go to the trace section and I will show you the function called trace to know that, where exactly we are taking more time, right? And lastly, we will deploy a change to address the latency issue and show that this alert goes away. And in the last part of this lab, we will basically do the profiling, and I will show you how we can look at the profiling. And with the profiling, we'll get some nice charts which show us what each function call, how much time it is taking, and that will allow us to kind of pinpoint if there is a specific issue in our code, right? Okay, so enough of talking. Let's jump to the lab now. Okay, so this is my incognito window. By the way, it's good to always have an incognito window with Qwiklabs so that there is no account confusion. All right, so let me log in with the the username and password that I got it created earlier. So I have to accept few terms and conditions. Let me accept that, get started. So the project is already set up for us. So we just have to select the particular project that is already set up for us. Right, the project is set up now. So next thing what we will do is we'll create a terminal, and the terminal is nothing but a temporary VM for us to work with this particular project. Let's make this a little bigger. So let's at least have 3 terminals so that we can kind of do a bunch of operations here. And in addition, we will also set up an IDE which we will use to look at the code. So the IDE is already built for us inside. So let's just go to the IDE. All right, let's make this a little bigger. Okay, so now this is set up for us. The IDE is set up. Now let's go and start the deploying the application. I think the first step for us is setting the zone. So let's start with that first step. Let me set the zone. Let me set the project. And let's look at the cluster. So in this case, as I told you, right, the cluster is already should be created. So I see that a cluster is already created. Let's also open a bunch of console windows. I think we need a whole bunch of them. The reason is we are going to do different monitoring and logging, and we're going to also look at APM. So it's easier to jump between different windows. So just have few windows open. It's easier to look at things. Make it a little bigger. Okay, so now that is done, let's go back to the terminal. Okay, so cluster is created. So let's look at the cluster from the Cloud Shell. So let's close this. So it's the same cluster that we saw in the terminal. Just wanted to make sure we are good here. Okay, so this is a cluster with 4 nodes that has been created. So let's go back to the shell. Let's basically let's go to another window and set up monitoring. So basically I go here. So basically first time when you start the monitoring in the project, the workspace gets created, the monitoring workspace, and with this particular project, right? And obviously you can add more projects later to the workspace. But so in this case, I'm just creating a monitoring workspace. So it says building your workspace. This takes around 30 to 60 seconds. Let it get built. Okay, so after that, let me look at the cluster from the console. So let me get the cluster credentials and look at the nodes. and I should see 4 nodes here. Okay, I see the 4 nodes. And the next step is I want to deploy the application. So let me clone the application, and I can create a soft link and create it. It's almost done from the cloning perspective, after which what we can do is set up a soft link to this directory. So let me do that, and then we'll install Scaffold. As I said, Scaffold is our local development environment. So after installing the Scaffold, let's it will automatically run through it. So let's basically start that. Okay, so now Scaffold run is what we have run here. So this is going to do the installation. So here we can see all the pods getting created, and after which we can look at the pods, and it's going to be most of them are starting to get created now. Just wait for a second for it to get created. Okay, let's look at the pod status. Okay, most of the pods are running. So now what we will do is we'll look at the external IP that gets created for this service, and let's see if the external IP is set up now. Okay, the IP is set up. Now we will do a curl to that external IP, and we see a return code of 200. So that is good. In the meantime, what we can also do is go here and look at the services and the ingress, and we can look at the front-end ingress, and we can go to the service and see that if I be able to access the hipster shop, right? So this is the hipster shop that is the web e-commerce application which composed of multiple microservices that is running here successfully. The last step we will do from a setup perspective is we'll download the code itself so that we can look at the code, and I want to show you how the instrumentation has been done. So let that go through. So it's going to just download the code locally. In the meantime, what we will do is I want to quickly show you the monitoring aspect, right? So the monitoring dashboard is built here. So there are two different ways in which we can do monitoring, right? One is we come to this monitoring central location, and here we can look at metrics explorer or the dashboard. I think first let me show you the dashboard, how it works. Here we can go to a GKE dashboard. This is a pre-built dashboard for us, and here I can look at, it's pretty nice, this dashboard, because it gives me one central place for me to see everything in a nice drill down fashion. So for example, I am looking at one of my workload view, and in this case I've deployed the application in the default namespace, and I say if I look at the default namespace, I can see all my deployments. And let's say if I go to one of the deployment, I can see the pod running. If I go inside, I see the container running, and for each one of these different types, right, I can even see the CPU monitoring right in one single central location, right? So this drill down view is in general nice to look at things in a very nice very fast fashion. The other way is you can go to the metrics explorer, and you can look at any of the metrics that you want to look at. And so what you can do is, let's say for for Kubernetes container metrics, I go to the container metrics, and I can say I want to look at my limit utilization, and I can group by pods, so I can see all pod level memory statistics in one single location, right? So this is this is still available in the central dashboard, and you can view that. Now the third option that I have not told is, so first you go to your workloads view, and here let's say if you're going to one of the services or the deployments, so here you can still look at all the statistics at this one single location, and you can even look at things like your YAML file, your events, and you can, let's say if you drill down to the particular pod, you can go there and look at the similar kind of statistics. Not just that, right, you can also look at the logs for this particular container directly from here. So if you click on this container logs, it directly goes to the logs viewer with the labels that we have pre-set up, and we can look at these logs, right? It's pretty nice from an integration perspective. Now this is one way to go and look at the logs. The other way is if you go to the logs viewer tab, you can go here and look at logs from a cluster level, a container level, a node level, or a pod level, right? And you can even directly go to and select a specific container and look at the logs associated with that container, right? It's pretty powerful that way. Okay, so what I said is I'm going to create an alert, and I showed you how the alert would look like, right? First, let me go to the metrics explorer, and let me go and create a new alert or a new alert policy, and I call this as a latency policy, and I'm going to add a condition, and the condition is I'm going to look at one of my metrics. So I'm going to look at a round trip latency metric. So if I look at this latency metric, let me select this, and then I will select a global resource here, and I select a task, open census task, which is this particular front end. I'm going to monitor the front end service, right? So that's what I'm going to select, and then I'm going to select a 99th percentile, and what I'm going to do here is that I'm going to set a condition if the threshold is more than 2 seconds. So if the threshold is more than 2 seconds for a 1 minute period, for this particular front-end service, I am going to create an alert. So let me add this particular alert, and this is the alert that I see, and then I'm going to save this alert here, right? So this is the latency policy I have set up. Now what we can also do is that I am seeing this, and if you see here, right, from a policy perspective, the latency is less than 2 seconds, and that's kind of what we see. And what we can also do, what I wanted to show is how is this parameters read, right? So let's go and look at our code. So let me show you a few things here. So let's look at the front end code, and I want to show you what kind of instrumentation we have done, right? If I go to the main.go file here, the two important things that you want to see is I have imported a bunch of open census libraries and a profiler library, right? So with this, what I wanted to show you is, so if I search for what I have done, so here I have set up an open census handler and an instrumentation, right? So basically that is what will allow me to, so once I import the libraries and do the instrumentation in the code, all those gets collected within Stackdriver and shows up in a central location, right? So that's kind of what I wanted to show you. Okay, so this is basically the good scenario, right, where our latency is less than 2 seconds. What we will do is we will generate a test deployment, which will add latency, right, and we will show you how the alert would come and get notified to us, right? So for that, what we will have to do is we'll have to change the code a little bit. So I will show you that. So first, what we'll have to do is I have to go back to my code and create. So let me go to my Kubernetes manifest, and I have to change basically the image version, right? And what I will do is use an image version which has a bug associated with it. So I go to my front-end service, and instead of this particular label, I will select a new label which has the bug associated with that, and I will select the policy to always pull the image, save it. Right, once I do that, then I can deploy the new version, and then deploying the new version is very simple. All I have to do is a scaffold run. So I do my scaffold run, and this is going to do the new deployment, and we just have to wait for a minute for the new deployment to be successful. Right, it is done. Let's just wait for around 20 to 30 seconds for the older ports to get deleted and the newer ports to come up. All right, so most of it is already running now, so we can see everything is running. So let's go back to our metrics explorer, and what we will have to do is change the because a new front end gets deployed, right? We just have to change the condition to update the new front end deployment here. So I'm going to delete that particular filter and create a new filter. It's still not yet up. Let's just wait for a minute for the new port to show up. If we look at what is the ports, I think we need to have a front-end port with 88B available. Okay, so let's look at the filter now and see if the new one is available. Okay, so we see the 88B, which is a new front-end port, right? So we just apply that. Let's just wait for a minute for it to come up. And in the meantime, what we will do is we will basically go to our hipster shop, we'll refresh it, we'll do a bunch of shopping here so that we get the statistics updated. So let's just buy a couple of them. I think the deployment is maybe still going on. It's a little bit slow at this point. Okay, let's place that order. Let's add one more. Add to cart. Okay, so while this is coming, right, so we have done few shoppings. Let's go back to our metrics explorer now. Okay, so now we can see that our latency has increased to a lot higher number. Now let's go back to our alerting window, and okay, here also we see our latency has shot up to much more than 2 seconds. So our alert we set up was at 2 seconds. So if we go back to our alerting window, it will take some time. I think it takes around 2 to 3 minutes for the alerting to show up here. It's basically a new incident to show up there, right? So while that is coming up, what we will do now is we'll go to the tracing, right? I wanted to show you tracing to see who exactly is taking time, right? So let's go to the trace. Let's go to the trace list. And the trace list basically shows you how the different services are talking to each other. And we can see that in the x-axis we see the time, and the y-axis we see the latency. Let's pick some of them which are outliers here, right? So let's look at one of them outlier here, and let's look at the events here. So if you look here, the list products. Okay, let's pick something else. Let's pick this one. Okay, so here basically the bug that we introduced was that basically the get product is going to call the list recommendations, and the list recommendations is the one which had a problem, and it was taking more than 3 seconds. And using this profiling path, we can say that which particular service is taking more time. In this case, it's a recommendation service that is taking more time, and that will allow us to kind of debug the specific problem, right? So that's kind of what the profiling view is going to tell us. And in the meantime, what we'll also do is in another window, we will start the tracing. So what we did earlier was the tracing, and now what we will do is the profiling. So let's go and start the profiler here, and the profiler takes some time to update, so that's why I kind of wanted to start it for it to kind of come up. And the profiler is basically, we'll set up a time span of 30 minutes, and let's wait for it to come up. So let's go back now to see if our alerting has kicked off. So now let's go back to our alerting window, and now we can see that the incident is fired. Basically, this is the incident is fired because the latency is more than 2 seconds. And what we can do is we can go to the specific incident, and this is the condition which says it's 2000, more than 2000 for 1 minute, and the actual latency is 4.4. and we can see the graph here, and we can acknowledge the incident. So once the incident is acknowledged, we can, let's say we acknowledge the incident, we go and fix the particular problem. Once we fix the problem, we can say I have resolved the incident. So that's typically the SRE workflow, right, in terms of how you can solve this whole thing. In this particular case, I have shown one alerting, the alerting with respect to latency, right? And we can set up multiple alerts. Actually, I wanted to show one more alert based on the availability of the service. Because of the lack of time, I'm not able to show that. But in that particular case, what we will do is look at the errors from the log, and from that we will generate a metric, and from that particular metric we can set up an availability policy, right, for that. So we can do that. But the last thing I kind of wanted to show, as I told you earlier, is the profiling, right? So let's go back to my profiler tab, just refresh it. The profiler gets the statistics from the instrumentation we have already done to the code. So let's look at the CPU time is what we will look at, and let's look at for one of the servers, which is the front-end service, right? So here what we will see here is basically the x-axis is the time that is taken, and the y-axis is the function call actually. So that's kind of how you can read through it. I think it's still not yet fully updated, so let's just wait for a minute. Okay, so I think from because of the lack of time, I'm not going to spend looking at the whole thing, but basically what we can see is here we can look at the complete function stack, and we can kind of debug which particular function in our code. Okay, now it got updated. So now let's say, for example, if I look at view caught handler, I can, or get recommendations, I can go and look at what particular function within that is taking more time, right? So that's the way you can use your profiler to find out which sections of the code actually is taking more problem. So now that we have done with this, let's go back to the slides. Okay, so basically summarizing what we have done, right, in this particular lab, what we have done is first is we have deployed the application that we talked about here, which is a microservices based application. We looked at some basic monitoring and logging. Then what we did is we set up a service level objective for latency for one of the front-end services. We deployed a buggy application and showed that we received an alert, and we saw that in the alerting window we acknowledged the alert. We also looked at the APM features like tracing and profiling to how we can debug the app. So this is how typically, using all the functionalities that is provided by GKE with the operations dashboard, you can kind of debug your microservices based application. So there are one more lab after you finish this, you can do that, which is called as Kubernetes Monitoring. This lab is useful because what we have shown in the previous lab is we did not monitor any application level metrics, right? This particular lab, what it shows is to instrument your application with Prometheus metrics, and those Prometheus metrics gets exported to Stackdriver, and you can see not just your system metrics, you can also see the application metrics in a single location, right? So that's value add if you want to try this particular lab. Okay, so now let's go back. I'll want to project the lab QR code itself. Just to reiterate, use this particular link, this particular QR code, and after you sign up, you will get 1 month of free lab access. Strongly encourage you to use that. So just going back, so what we covered in this lab is the troubleshooting with Google Kubernetes Engine. In the next part, which is the last part in this series, we will talk about how to deploy a serverless application on top of Google Kubernetes Engine. Hope you had fun watching this, and I'm hoping you will try this lab. Thanks for watching. Bye.